Hi everyone, I'm Sanjay Xu. I'm going to talk about our work ComSetElf, which to the best of my knowledge is the first verified C compiler that generates object files in a standard format, in our case the executable and linkable format, or ELF. Moreover, we propose an approach to enhancing ComSetElf for supporting separate compilation. This makes ComSetElf the first verified compiler that supports separate compilation from C all the way to the object file. Previously, the authors of this paper developed a stack-aware ComSert, an extension of ComSert that compiles C program into a language called RealASM. RealASM is a language with a realistic semantics for assembly programs. ComSetElf further extends stack-aware ComSert with a verified assembler for RealASM that generates ELF files. A RealASM program is considered as a map from names to definitions. On the other hand, an object file consists of a set of consecutive binary blocks called sections, where symbols are referred by address. Our assembler first transforms definitions into sections and generates the symbol table. It then generates relocation information for sections. Finally, it encodes these tables, sections, and ELF metadata into their binary form. The key passes of ComSetElf are symbol table generation and instruction encoding. For the symbol table generation pass, the main difficulty is proving an invariant between memory states, that is, a memory injection, under the reordering of memory initialization operations. To prove the correctness of instruction encoding, we first decode the binary program and then prove the decoded result semantic is the same as the original one. The final correctness theorem states that the compilation of ComSetElf preserves the behavior of programs. Next, I'm going to talk about the verified separate compilation for ComSetElf. Separate compilation is critical for organizing programs consisting of multiple modules. To verify separate compilation using the same compiler is sufficient to prove commutativity between compilation and linking. That is, given a set of source modules, you could first compile it and then link in the compilation result, or you could first link in the source modules and then compile the linked result. The final program should be the same. As we depicted before, source programs are in essence maps of definitions, while ELF programs are set of binary sections that are treated as black boxes. The ELF linker simply concatenates the sections of the same type together, without performing reordering, among other analyses. On the other hand, source-level linkers could organize definitions in any order, breaking the compiler's commutativity. We introduce a general solution to this problem. It has two ingredients: syntactical equivalence and order linking. First, when linking RealASM programs, the order linker keeps the order of definitions, just like they've already been merged into sections. This imitates how the ELF linker works at the source level. By inserting an extra syntactical equivalent pass along arbitrary permutation of definitions, we are able to translate from the source linker to the order linker. After the transition, the commutativity is restored. Then here comes the complete separate compilation theorem. Now welcome to the demo part. First, let's look at the example files. There are 6 symbols in the main file. 2 of them are external functions and 2 of them are global variables, and the other 2 are the local functions. In the main function, there's a loop. In each loop, it will call the incr function and the get function. There's another function called record. Record just writes its parameter into an array and then print it out. And in counter, there's a global variable called c. C is initialized to 0. And for each time the incr function is called, it will record c and add the c by 1. To use the ComSetElf, we just need to add the option RELF. As we can see in the trees, these passes are added in the ComSetElf. Now let's check the ELF file. The ELF file contains a symbol table and relocation table. We can see the symbol name here. Finally, we can check the compilation result is correct. ComSetElf can also support the test cases under the C directory comes with ComSert. Also, it could compile a large project called compression. If you are interested, please come to my talk. Thank you for your time.